So this is a question, June 1841 variant, question number 5, and topic is kinematics. In the worksheet, the question number 113. So let's see how we can do it. So first of all, a sprinter run his total meter is 200-meter distance, and his total time for the running is a 20 seconds. Clear. So he starts from rest, okay, and accelerate uniform for 6 seconds. So 6 second acceleration, reaching speed of 12. Okay, and then the maintenance speed for 10 seconds next, and then he decelerate. Okay, if I quickly, roughly, I make an idea, so it means very clear. First, he start for 6 second acceleration, so 6 second. It means this 6 second. Okay, and gain a speed of how much? Start 12. So it means this. Okay, clear. So then he maintains for next 10 seconds. So 10 plus 6 give you 16. So let's say 16 and straight line. Why, sir? Because 12, 12, 12, and 12. So throughout this, the speed is 12. Okay. After there's a straight line parallel to x-axis. Make sure. Okay. And then he's decelerating and finishing line with the speed of v. It means will not meet ground. No, 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 no. It means it is somewhere here, because and this speed is v. So this speed is v. So this is a whole idea. I think you have done just similar kind of question just recently. Okay. So let me make it dotted line. You can understand. Okay. And dotted line even. So this is a velocity time graph. So he said find distance traveled by sprinter in first 16. So first 16. Okay. Then he said find sketch distance time graph. Okay. In first 20 seconds. So we have to make it 20 seconds. Okay. Let's start. And mention 20 cent total. So this is total 20. So this is a confirmed 20 here. All right. Okay. Bismillah ar-Rahman ar-Rahim. This is a rough idea because he's not asking us to make it. All right. So find distance travel. Bismillah ar-Rahman ar-Rahim. First part. So how to find the first part? Okay. Distance travel. So we have we will look at carefully. We have a trapezium. This is a trapezium. I think you can see clearly. Okay. I'm doing it is up and I have space issue. So I'm writing on the top. Okay. And okay. So what is the travel? So distance travel is actually half into h into b, a plus b. Trapezium formula. Okay, I just make a rough diagram here. So you understand this is called A, this is called B, and this is called H. H is 12. How? Because this gap is 12. Okay, and clear. And A is what? 16. So I'm writing here 16. And this gap is 10. So this gap is 10. So it means this becomes 10. So first part is very clear. Height is 12. A is 10 and B, okay, no problem, 16 plus 10. Okay, and I'm getting this answer 6 times 2, 26. It is coming 156. So it means 156 meter distance we have here. Okay, all right, this is very, very clear. Okay, but I think I can, one reason behind it. Okay, I'll talk later about that. Let's move on. Next point. This point is very, very clear to you. So hence sketch the displacement for the first 20 seconds. This is the interesting part we have. So let's see now how we can make it. Problem is that this distance we must know, this distance we must know, and this distance we must know. You ask why we know, sir? Because if you don't have these three distances, you cannot make a sketching of the distance time graph. So first of all, so I need this triangle area. So triangle area is so simple, half into base into height. So I'm finding half into base 6, height is 12. This is coming 36. So this is 36. Okay, and the second is a rectangle. So there's a 10 and there's a 12. So 120. So this will come here 10 times 2, 12, 120. So 120 is very, very clear. There's a 120. Okay, now question comes, total is a 200 meter. All of you know it. Okay, so from 200 subtract 156. So when subtract 200 156, it is coming 44. So these are 44 meters. All right. So it means you got all three distances. Okay. Even you show to examiner, I think so better. So better to show that top, not do triangle way, but better do not do trapezium way. Better do a triangle way. So half into base into height and length into width, length into width. So half into base. Base is you can see base is 6 and height is 12. Okay. So 6 into 12. Okay. This is a separate I found D1. and D2 is what? This 10 and this 12, because width into height. Okay, so it is coming 10 times to 12. So this I got, I think, very clear. I got of this one. First answer is coming 130. This is coming 36, and this coming 120. Oh, coming 156. So actually, indirectly, I have all distances. We can say that distance one is 36. Distance 2, we have 120. And distance 3, we have 44. How I got 44? So from 200, subtract 156, we got 44. So this working you showing to examiner actually. Okay. So I'm leaving it here, meters, meters, and meters. Now I'm going to start my actual sketching. Bismillah ar-Rahman ar-Rahim. So let's start sketching. Okay, what is criteria of sketching? Let me show you what is method. Okay, I show you inshallah. Okay, when you sketching, all total time is 20 seconds. Total time is 20 seconds. So I will make 20 along x-axis, but make sure this 6, 16, 20 must be there. Okay, let's start. So I think so 2, 4, 6, this 6, 8, 10, 12, this 12, this 14, and this 16. So I think I should show 16 only. So 16 only. So no problem. You can show even rest even. So 18 and 20. Repeat. 2, 4, 6, 8, 10, 12. I think I missed one value here. See, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Correct. So I got it all this right here, time in seconds. Okay, and let's talk about the S is in meters. Okay, so distance in meters. Let's start. How much total distance we have? It is a very clear is a 200 meters distance. So it means you have to divide this region such a way you must get 200 meters. So let's see. So if I 200 is somewhere here, so 100 is in the middle somewhere here. Now I think the part divide to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think idea is very clear. So let's start. First of all, I will mark. So, and when time is 6, distance 36. So time is 6, then 36. What is 36? 20, 40. So 40. So this is a somewhere here, 36. So 36 is somewhere here. Okay. So when after that, if 36 and 120 add, you got 156. Where is 156? So because in 36, I will add 120. So 156. So 100, 20, 40, 60. So it is close to 20, 40, something here, somewhere here, 156. All right, students, let's start. So I have a pointers. First pointer 6 and 36. So 6 is here and 36 here. Let's start. And you know that first part is acceleration. So you will show this graph. Wait a minute. Bismillah ar-Rahman ar-Rahim.
It will be curved, right?
Yes, curve. Yes, yes, yes. It is 100% curve, my son. You're right, because it is like this. My hand is not as smooth. I'll try my best. Wait a minute again. I think now better. No, no, still it is not that good. Okay, now okay. And then it will go straight for how much time? 16 minus 10 become 10 seconds. So it means 10 seconds straight line. So straight line I can show with my tools. It is a okay. One more thing. So sorry, 16 and sorry. It is a time is 16 and total distance is 156. Why, sir? Because if you add them both, so 156. So 156 is here and 16 is here. So I mark. Wait a minute. I mark. I show the line. Then you can understand better. This, this. Oh, it means that they're meeting here, here. Okay, I rub the lines now. Okay, I got a point. So let's start. Bismillah ar-Rahman ar-Rahim. Okay, done. And now this is a, I think idea is clear. And now deceleration. For how much time? It is very clear. It's a 4 seconds. Okay, 4 second means here. And how much distance told is a 200. Confirm 220. So let's try to meet. So 200. Let me make a line and you can understand inshallah. 200, 220. Okay, they meet here, my children. Okay, and I rub the rest one. So now I have to just meet them. But you know, meeting criteria is what? Actually, my curve is not because I am doing on a computer on a screen. So anyway, this is a little bit bend. This kind of bending. Okay, here and this bending is the other kind of bending. This because this is called acceleration bending, okay, and this is called deceleration bending. Is very, very clear. So alhamdulillah rabbil alameen, I try my best. Let me erase it because I'm not happy with this curve. This curve is not that much good, but I try to make again. Then I think now it's better than before. Okay, it's the better than before. So we have done it. Last part, he's asking velocity. Which velocity he is asking here? He said that ending speed. If you remember, we have done just one question before. So how to find this one? So I can find it by, okay, I'm doing here. So all of you know the distance for last moment is a 44. So I can say that area of that last trapezium is 44. So I'm writing trapezium formula. This is a part number 2. Okay, part number 2. So let's start. So area is equals to half into h into a plus b. So I'll make a rough idea. So look at, this is a trapezium which you are dealing now, and distance is 44 meter, my children. And this is a clear, and this is a 12, and this is a v. How come, sir? Look at here. This gap is 12, so I wrote 12, and this gap is v, so I write v. Alhamdulillah. And this gap is how much? 4. So this gap is 4. So 4. I'm writing here now. So let's start. Height is 4, A is 12, and V is V. Second is a V, and area is 44. So I'm going to finish now. This is 2 cancel 2. Okay, I'm just doing shortcut because it's not a hard calculation. You can do yourself. I got 22 is equals to 12 plus V, and V becomes Alhamdulillahi Rabbil Alameen 10 meter per second. So I think this idea is very, very clear.